what we're going to do now is to start this table and fill it in. If we are at F, which is state 1, we've only got one action, that is going to D. What is the cost of going to D?
8.
So you can put that in the value column.
8.
If we are at C, we only have one action, that's going to D. What is the cost of that action? 7. Okay. Now, in this one, in each state, we've only got one entry. Further down here, we will have multiple entries in each state. And what you now do is this. For each state, you arrow the minimum value. So here, in this state, there's only one value, it's 8. You arrow it. And this is a minimizing question, so we're looking for our minimum value in that state. Here, there's only one to choose. But if you look down here, there are going to be 3 we could choose. And in here, again, there's only one there we could choose, and we're choosing our minimums. So, because this is the first one we're doing, if you could actually write down, what we do is for each state, we are arrowing the minimum. Now we're going to work backwards into stage 2. Effectively, what we have said now is that if we are in any of these stage 1 things, we know what the best thing to do is. If we're at F, the best thing to do is down there, and if we're at C, the best thing to do is there. Well, they were the only choices we had in that one. So next, if we are at E, we have options are going to either F or to D or to C. If we go from E to F, what is the cost of going from E to F according to the network? 3. And given we are at F, now you need to watch what I'm doing please, given we're now at F, you work up the table to where you see this letter in a state column, which is here. What was the optimal cost of doing things from F?
8.
8. So you add that 8 on, which gives you 11. If we move down to the next one here, we're at E. What is the cost of getting to D? 12. And now that is actually the end one, so there's nothing else to add on to that one.
Brilliant.
If we're at E, going to C, what's the cost of moving from E to C?
3.
3.
Yeah.
Now C, you look back up in the previous stage until you find C, and from C the optimal solution has a value of 7, so you add that 7 on, and that then gives you 10. Now you have finished that state. What is the minimum value in that state? Yeah, this 10 here. So you arrow that 10, label that the minimum. And because this is the first time we've done it, can we star, maybe in a different colour, so we star that 8 and just show that 8 is that 8 up there. And maybe some other sort of notation, mark that 7 and show that is that 7 over there. And if we can just write down some explanation of what we've done, here we looked for F in the stage above and added that value to the 3, and that 3 was the cost of moving from E to F. And we've now finished stage 2. So we move on to stage 3. Stage 3 has 2 states. State 3.1, which is G, we've already said we can go to F or to go to E. What is the cost of going from G to E? Sorry, from G to F first I should be asking. G to F. G to F is 5. Now we look to find F in a stage above. Well, that's in the top stage, stage 1. What is the value associated with it? 8. So we have a 5 plus an 8 there to give us 13. The next row, G to E. G to E in the network is a 3. Now we need to find E in a higher up state, higher up stage on the diagram. Well, E is here. And E, what is the best value for E?
10.
Yes, it's the 10 that we arrowed here. So in that state, you find the arrowed one, which is 10. So we add that to a 10 and we get a 13. We've now finished a state. So we choose the minimum of these two. And if there's a tie, it doesn't matter which. So we usually just go for the top one. So we'll label that top 13 there as a minimum. And can we make a note there, it's the first time, for a tie, you can choose either. Staying in stage 3, but the state 3-2, which is B, B to E, what is the cost of going B to E? 6. And E, again, we look for E in a higher stage, and the best value in that state was 10. So we add on a 10 to give 16. And B to C, on the network diagram, B to C is 6. We now need to find C in a higher stage, which is up here, and that had a minimum arrowed value of 7, which gives us 13. And out of the 16 and the 13, our minimum value is a 13, so we arrow that. Moves us on to stage 4. H to G, some of you may have gone on and done this already. H to G is 6. We need to find G in an earlier stage, that is here. And in that state, the best one was 13. So we get a value of 19. H to E has a network value of 9. We need to find this E in an earlier stage, that's up here. And the minimum was 10. That's 19, it's a tie. We'll choose the top one. Still on stage 4, but in state 2. A to E is 5. We already just weighed out from E, we need to add on a 10.
A to E is 7.
A to E, sorry, yes, I've looked at the wrong one. Thank you very much. So that's 7, so that's 17. A to B is the 5. We need to find a B higher up. That will be here. The arrowed one was 13. That gives us an 18. 17 is the minimum. So what we have found out now is we can get through this network in a minimum of 17. And what we need to do now is to backtrack through and work out how we got there.